In this video, we are going to go through the review of financial mathematics for the CPA Australia's financial risk management module. So first we'll look at the future value of a single cash flow. So today there will be a cash flow denoted as PV sub 0 that will earn interest at a rate of R% per period for n periods. And at the end of n periods, the future value of that cash flow will be represented by FV sub n, and this is equals to the initial present value multiplied by 1 plus the interest rate and then to the power of n. So this assumes a compounded interest basis. Now let's look at example 1, where we'll calculate the future value of $100,000 invested at the interest rate of 8% per annum at the end of 5 years. So at the timeline, there will be 100,000 invested at time 0 up to year 5. So in this case, we'll take 100,000 multiplied by 1 plus 0.08 to the power of 5, and that will be equals to $146,933. Okay, if you round up to the nearest whole number. If you're using a scientific calculator, you will type 100,000 multiplied by bracket 1 plus 0.08 close bracket, and then the power button will be denoted as x to the power y, but you should be familiar with your calculator's function. Okay, so I'll type power, so you see a hat here, and then 5, and then it equals to 146,933. So that's just to confirm the answer. Next, I will move on to present value of a single cash flow. So now, if you know the future value, okay, or the cash flow in the future, that is at period n, and you want to know the value of that cash flow today, which is PV sub 0, then we'll just take the future value, divide by 1 plus the interest rate, and then to the power of n. Example 2 here, let's calculate the present value of $10,000 at the end of 6 years, assuming the interest rate is 10% per annum. With the timeline, we have $10,000 in year 6, and I want to find the value of this cash flow today, okay, at time 0. So we'll take $10,000 divided by 1 plus 0.1, which is 10% to the power of 6. So that's $5,645. So in other words, if you want to have $10,000 in your account at the end of 6 years, then you have to invest averagely $5,645 today. And that assumes that the interest rate will be 10% fixed for the next 6 years. Now, let's look at future value of a series of cash flows. So if there's a series of cash flows, okay, and these cash flows are denoted by C1, C2 up to Cn. So every year there will be different cash flows. And to find the future value of all these cash flows up to year end, all you need to do is just to find the future value of each cash flow, and then we'll compound it to year end. Of course, for the final, if there's a final cash flow in year end itself, there is no need to compound it because it is already at that period. Now let's look at example 3, where we'll calculate the future value at the end of year 3 for this series of cash flows of $200 in year 1, $400 in year 2, and $600 in year 3, and assume that the interest rate is 8% per annum. So what we'll do now is I'll take each of these cash flow and I will compound it. I will, like for example, $200, I'll multiply it by 1.08 to the power of 2 so that it compounds to year 3. And then for $400, I'll compound it by 8% for 1 year. And for $600, there's no need to compound anything because we are trying to focus or pull all the numbers up to year 3. So for the first $200 here, okay, if you were to compound it to year 3, that will be equals to $233.28. Okay, and then for the $400, that will be multiplied by 1.08, so that will be equals to $432 in year 3. And then lastly, for the last $600, there is no need to compound anything there because you're already at year 3. So the total of this will be the future value of the cash flows in year 3, that's $1,265.28. Now, if you want to find the present value of a series of cash flows, what we'll need to do again is for each of the cash flow, we will take the present value, okay, and we'll present value it up to, let's say, period 0 in this case. So with as many cash flows as you have, you just have to discount them. and discount means that we'll divide it by 1 plus r to the power of the time period. In example 4, calculate the present value of the following cash flows, assuming an interest rate of 10% per annum. So again, if you draw out the timeline of the cash flows, and we'll discount each of these cash flows at 10% based on their timing, year 1, year 2, and year 3. So for the first cash flow, that will be equals to 181.82. And then for the second cash flow, that will be equals to 330.58. And for the last cash flow, that will be equals to 450.79. So that will be equals to $963.19. Another way of looking at this is that if you were to invest $963.19 today in this investment account, that will and this account earns 10% per year, it will allow the investor to receive or draw $200 in year 1, $400 in year 2, and $600 in year 3 by just investing this amount today. Next, we look at a perpetuity and how we calculate its present value. So when we say a perpetuity, it's a series of equal cash flows that goes on forever. And the formula that you see here, which is C, the cash flow, okay, the equal cash flow divided by the interest rate. This is assuming that the first cash flow happens at the end of the first period. So you will see that at time 0, there is no cash flow, 0. And the first cash flow happens 1 period from now. Okay, that's the assumption of this formula. Keep that in mind. So in example 5, let's say investor leases a parcel of land for an equal annual payment of $20,000 per year forever. And the first payment is made at the end of year 1. So if the interest rate is 8% per annum, what is the present value of this perpetuity? So the 20,000 occurs forever, okay, up to infinity. So the present value will be 20,000 divided by the interest rate 8%. So that will be equals to $250,000. So that's the value of this series of perpetual $20,000 payments. Now for the present value of an annuity, annuity means a series of equal cash flows and it occurs over n periods. So for the perpetuity that we saw earlier, equal cash flows are also a form of annuity, but it goes on forever. Okay, but in general, annuity will happen over n periods, but most importantly, the cash flows are equal. And the first cash flow occurs at the end of the first period. So again, there's no cash flow at time 0. And to find the present value, we'll just discount all the equal cash flows based on the interest rate. And a short form of it will be to take this formula, which is the cash flow divided by R, and then we multiply by 1 minus 1 over 1 plus R to the power of n. Now for some, you can also express the formulas in this way. We can take C over R, multiply by 1 minus 1 plus R to the power of negative n. Okay, so that is based on the fact that 1 over x is equals to x to the power of negative 1. Okay, so that's how we convert this fraction to this negative power. Now let's look at example 6. An investor is considering an investment that pays an equal cash flow of $5,000 per year at the end of each of the next 8 years. And the interest rate is 10% per annum. Calculate the present value of this annuity. So the equal cash flow is $5,000 per year starting from year 1 up to end of year 8. So the present value will be to discount all these cash flows for 8 years, but that can be very tedious. So we'll make use of this formula. So the equal cash flow will be 5,000 divided by 10%, multiplied by 1 minus 1 over 1.1 to the power of 8, because it's up to year 8. And then that will be equals to $26,675. So in other words, if I invest this amount of money today, and it earns 10% per annum, I will be able to receive $5,000 per year for 8 years. Now let's move on to a growing perpetuity. So earlier we saw a present value of a perpetuity where the cash flows are equal every year. But what if the cash flow grows at a constant rate forever? So in this case, we have the first cash flow, C sub 1, that happens at the end of period 1, and this cash flow grows at a constant rate of G% per period. So each period you will multiply by 1 plus G. So the short form for this formula will be the cash flow in the first period, C1 over R minus G. That will give you the PV at time 0. So always make sure that, remember, to find the value at time 0, we always start with the cash flow 1 period later, which is C1. So if you are trying to calculate the value of these cash flows at time 1, then you will use C2 in this formula. Now, example 7, an investor is considering an investment that pays a cash flow of $5,000 next year, which is in period 1, with subsequent payments increasing at a constant annual rate of 4% per annum forever. And the interest rate is 10% per annum. Calculate the present value of this growing perpetuity. So we'll take $5,000, this is in the first year, and then it will grow at a rate of 4% every year up to perpetuity. So when you're calculating the present value, we will start by taking $5,000 and then you divide by 10% minus the growth rate. So that's equals to $83,333.